Hi, welcome back. In this video, we're going to talk about areas of circles and sectors. Before we begin, let's talk about how to find the area of a circle. This will help us review a little bit. In this example that you see here, we have a circle with a radius of 3 units. The general area of a circle is pi r squared. Now we're looking for the amount of shaded space within the circle. In our last video, we spoke about circumference, and we spoke about how to find the distance around the circle. Now we're looking for how much space is within it. So we take our radius, we plug it in here, we have pi times our radius squared. So we can put 3 squared. If we wanted to leave this in terms of pi, we would just do the 3 squared part and would say this is 9 pi. If we're trying to avoid decimals. Or we can leave this, we can actually plug in the calculator and say the area equals 9 times 3.14. And that comes out to about 28.3. What does this mean? It means that if we were to count all the squares inside the circle, we would get about 28 little squares. Now, we want to talk about the area of a circle and the area of a sector. A sector is known as a section of the circle. So if we have this full circle, and we only want to find the area of a piece, this is going to be very similar to arc length that we spoke about before. For arc length, we wanted the circumference and then a piece of the circumference. Now we're looking at the area of a sector, which is the area of the circle or a piece of the area of the circle. So the general formula looks like this. For area of a sector, we take the area of the circle and we multiply it by the desired region. What angle do we have here? Right? However big the sector is, we multiply the area by that portion. So since the area of a circle is pi r squared, the equation would actually look like this. Pi r squared times whatever angle we're looking for over 360. Our goal today is to talk about how to find missing values, how to find the area of a sector, how to find a missing radius, a missing angle, how to find different things given this relationship. Let's try a few examples. As you can see here, we're trying to find the area of 2 sectors. On the first one, let's write our general formula here in the top. Area of sector. This is the area of the circle times the angle over 360. So, to find the area of this circle, we would do pi times 18 squared. And then the angle of interest here is 40 degrees. So to find this shaded region, we just have to multiply it by 40 over 360. I'm going to plug everything in the calculator except for pi, because I want to be able to show this in 2 forms. So this equals 36 pi. Sometimes we want to leave things in terms of pi so we can avoid decimals. If we want to find it in decimal form, all we would have to do is plug in the rest and say 36 times pi, and that gives us 113.097. So sometimes we leave things in terms of pi, which means we plug everything in the calculator except for pi to avoid decimals, or we can plug everything in the calculator and get the value of 113.097. Try this next example. Why don't you press pause, use this formula, and see if you can do the area of this next sector over here. How do we find the area of this piece, this portion? So we have pi radius squared times the angle we want over 360. This should sort of look like the last equation we did for arc length. We did circumference, the full circumference times the angle over 360. Well, now since we're dealing with areas, it would be the full area times the angle over 360. In terms of pi, I have 8 squared times 135 divided by 360. This is just 24 pi. Or we can also leave it in decimal form, 24 times pi, and we get 75.4. And these are all square units. So whatever units we have, we square them. Okay? So as long as we know what we're looking for, we have the radius and the angle, we can find the area of a sector. How about we work backwards a little bit? Because given this equation, as long as you have some information, you can work backwards and find the angle that gives you an area. You can find the radius. You can find really anything you're looking for. So these next two examples are going to be about that. In this example, you can see that we're trying to find the radius of a circle, which has a sector area of 9 pi, and the central angle is 90. So let's draw a picture to see what that looks like. We have a circle whose central angle is 90 degrees. And the area of the sector is 9 pi. So the area here, it's already given to us. This area is 9 pi. Let's write a general formula so we can see what we're missing. So the area of a sector is the area of a circle times the angle of interest over 360. We know the area of the sector already is 9 pi, so let's replace that with 9 pi. We know the angle that we want is 90 degrees, so let's plug that over here, 90 over 360. And what we're trying to find is the radius. So if we plug in the formula for area of a circle, it's just pi r squared. Our goal here is to solve for a missing value. And as you can see, the thing that we're missing is r. Can we solve for r? Well, let's isolate the variable. How about we first get rid of pi? I can divide by pi here and divide by pi here, and that would cancel the pi's completely. This is why it's beneficial to leave things in terms of pi, because we don't have to multiply it by a decimal and then get rid of the decimal by dividing by more decimals. So getting rid of the pi's nicely leaves things in whole numbers. So now I have 9 equals radius squared times 90 over 360. Here, if I want to get rid of the 360, we can multiply both sides by 360. 9 times 360 is 3,240 times 90. To get rid of the 90, since we're solving for r, we want to divide both sides by 90. R squared equals 36. And now to get rid of the square, we do the inverse, which is square root both sides. I don't really have to worry about the plus or minus because we can't really have a negative radius. So we're just going to have a positive radius. This is the length of the radius of the circle that would create that area with this angle. So as long as we have our general equation, I'll put it over here. As long as we have a general equation, plug the information that we know, and then solve for whatever value is missing. Let's try another one. The central angle of a sector is 72, and the sector has an area of 5 pi. Find the diameter. We still want to start with the general equation. The general equation is area of a sector is equal to the area of a circle times the angle over 360. I'm going to draw a circle so I can sort of see what I'm working with. I know the central angle is 72, so this opening is 72 degrees. And the sector has an area of 5 pi. So if this were shaded, that area is equal to 5 pi. All right, well, let's plug some stuff into our general formula, and let's solve for what we're looking for. The area of a sector, the shaded region, was 5 pi, so we replace this portion of it. The area of a circle we don't know, but we know the general equation is just pi r squared. The angle we're working with is 72 degrees. Right? 72 is going to go in here over 360. We're solving for diameter. Before we solve for diameter, let's find the radius first. So let's isolate the variable. Let's get rid of pi. 5 equals the radius squared times the angle over 360. As a shortcut, instead of multiplying both sides by 360 and then getting rid of the 72, since we're multiplying all of this by r squared, we can also divide by that fraction, 72 divided by 360. And that way we can do it all in one fluid movement. Now the whole fraction can go away. We just need to make sure that we're dividing it correctly. So 5 divided by 72 over 360. And that's 25. Again, to get rid of the square, we do the inverse. We square root both sides. No need to account for the plus or minus, so we just say r equals positive 5. Now, we were interested in finding the diameter. And if we think back to our relationships of circles, the radius is always half of the diameter. So to find the diameter, we just take the radius and we multiply it by 2. So the diameter is 10 units. All right, guys, I hope this has helped. Don't forget to like the video, and if you haven't subscribed already, go ahead and do so right now. And as always, we'll calculate later.